I'm back with solid principles, and this is I interface segregation principle. Make fine-grained interfaces that are client specific. So if you're asking modules to implement interfaces, make sure you don't throw a huge interface that does everything and then ask everyone who needs just a piece of that to implement the whole thing. So the idea is related to single responsibility, is related to cohesion, and you're just going to make it easy for other modules and for other users to pick and choose what they need instead of getting a huge interface to implement. So here is a customer interface, and it has a lot of things, and you have your corporate customers, retail customers, and potential customers, but your potential customer does a lot less. So look at this design. So you have an interface for customer, an interface for product customer. So this is a customer in general, and I need all this information and behavior from them. And now I have those who purchase, and those implement another interface too. So those who purchase, they're here, and the potential customer who has not purchased anything goes down there. So you did a favor to this child. It doesn't need to do a lot of things that the other two are expected to do. So make your interfaces small and specialized, and then people can pick and choose and create a whole that is needed for them. Dependency inversion principle, that's the depend on abstractions, not on concretions. And some of you have already noticed this. When you created inheritance hierarchies in your domain model class diagram, you added the association links between parents, not children. And that's the idea. Parents should talk to each other, not children. Obviously, there may be reasons for you to violate this principle, but in general, we don't want you to do that if you can. So look at this. This is your power cable, and this is the power plug, and the two don't need to know details behind the services or the work they provide and do. They just talk to each other, and that's the high level connection. And if you were to use your wires, actual ones, connect them to the wires in the wall, that would be a violation of this principle. So if I'm a distributor of pieces of news, could share it on Twitter, share it on Facebook, but I shouldn't be needing to know details of how to post on Twitter and how to post on Facebook. Here I can share a post, and details of sharing on each platform could go under that platform. So I, as a distributor, I depend on a parent, and the parent knows how to provide the service using any of the children that can provide that service. So right now you may be noticing that these ideas are related to each other. Solid principles, some of them are related. So here we have parent-to-parent connection, and we are following Liskov principle, hopefully, otherwise this wouldn't work. So I have a customer repository. So this is probably a database thing. Customer would depend on interface, and the interface can be implemented by SQL repository or Oracle repository. So the customer does not depend on the details anymore. It depends on an interface, and the interface then will be taken care of by those that implement the behavior. So there are solid principles and there are anti-patterns, there are design patterns. All these are ideas out there to help you make better choices when you have multiple alternatives in your design. And some of you who worked harder or worked more on your assignments, probably did revisions, you already noticed that there are alternatives, and sometimes it's not easy to choose among different alternatives. These solid principles, cohesion, coupling, patterns, and anti-patterns, they're there to help you make choices that are appropriate for the application and the organization. So anti-pattern are things you don't want to do. The blob is a single class that does a lot of things for you. So probably someone didn't know a lot about object-oriented design, and they put all the workings of the software in one big class. And I've seen that in the past when we did have coding in this class. Students put everything in one big class. We don't want you to do that. And some people call this a God object, so powerful, it does everything. So changing, maintaining would be an issue here. And then we have here poltergeists, a lot of small classes that do a little for you, and some of them are rarely used. So this relates to your one of your solid principles. Think about that. SOLID. Which one of them, if taken to extreme, could cause this outcome? And I'm gonna give you a hint. It's I. Design patterns, again, they're there to help you. The original classic patterns came up many years ago when I was a student in college. Now there are many more. Some of them, they help you create objects in a way that it's appropriate for software. Some of them change you to adapt behavior when you need to. Some of them will take care of numbering if you need to create a certain number of objects. If you look at them, if you Google design patterns, you can find traces of cohesion, coupling, single responsibility, and so on in them. So all these ideas are related, but some of them are more specific or more prescriptive than others. And design patterns for sure are very prescriptive. They talk about the problem and they propose a solution, and they have been tried and they are good solutions. So it's worth just looking on the web and see how a few of them work. And an example here is an adapter, which takes care of kind of having different interfaces for different modules if your expectations of the system changes over time. Okay.